All right, let's continue on with blood and look more specifically at blood test and blood typing. So obviously when you hear about blood test and typing, usually is when somebody's going to be a donor and somebody's going to be a donee. So of course proper matching is very important. You mix up the wrong blood types, you're very likely might kill somebody. So you can't just throw any type of blood in someone you want. You probably all heard this before. Now there's many rules on that. Our books don't get into it. We're not going to go into an entire section on what blood types can be mixed and why, but let's look at some of the basics of it. Now obviously it's important for obvious reasons. You could kill someone if you put the wrong type of blood in them. We're going to see why. We're going to look at all this agglutination which could occur and see what happens. But as you've also heard, most people, most of anybody you're going to ever run into in your life is going to fall under the ABO-RH matching system. There's something like 35 blood types known worldwide, but most of those are really, really rare. So what we're doing with this ABO-RH matching system are looking at antigens and antibodies that each one of these individuals have. There's really just a few proteins that you need to look for on the surface in the cell membrane of red blood cells to get most anybody's blood type. So we'll see how that works. But let's look at a few of these terms you always see used with blood test. One here is antigens. Now if you were to look up on the internet in the back of any physiology book the word antigen, it's going to say any substance that stimulates an immune response, and that's correct. But when we look at typing at this time right here, think of antigens as surface proteins. Proteins on the surface of these red blood cells in their cell membrane. Blood types have been identified by the presence and absence of particular proteins. So your blood type depends on what proteins you have. Again, your DNA is largely a set of instructions for making proteins. So that's going to determine which ones can be there. Now, antibodies are proteins floating around in the watery parts of the body, whether it's plasma, interstitial fluid, whatever that may be right there. And you'll notice when we look at the blood types that antigen type and antibody type in a person should never match up. If you were to suddenly start making antibodies, which would respond to antigens you have, you would start destroying cells you don't want to destroy. It'd be an autoimmune disease. That's never going to be good right there. But if an antibody ever does match up with its one particular antigen, it'll clump those cells together, the proteins and whatever cells are connected to them, and that's going to cause their destruction. Hemolysing, the lysing of these cells, you don't want to lyse your own cells. Not a good idea, so that's why they ordinarily don't match up. So look at this little simple table right here. Most everyone you meet will fall under blood type A, B, or O. This couldn't be any simpler. If somebody has type A blood, it's because they have the A protein antigens on their reds. If they have B blood, they have the B proteins. If they have AB, they have both of them. And think of O as sort of being like neither. So notice not the A or the B will be found there. So look at that. Type tells you which antigen they have. Just remember the O means neither one of them right there. Simple as it could be. And as we just said, whatever antigens you have, antibodies will be the opposite. So if you got A blood and the A antigen proteins, you better not ever make anti-A antibodies. That would destroy your own red blood cells. So that's why antigen type and antibody type will always be opposite. So A blood, A antigens, anti-B antibodies. B blood, B antigens, anti-A. If you've got both proteins, then you can't have either antibody. Either one would destroy your own reds. And if you have neither protein, you'll have both antibodies. Again, notice how antigen and antibody are always opposite. And then what you always hear added to this right here is that positive or negative. Well, all you do for that is look for the presence or absence of another antigen, what's called the D antigen, more commonly called the Rh factor. So if you have this antigen here, instead of putting a letter by your blood type, you put a plus for positive, meaning you do have it, and a minus for negative if you don't. So let's say somebody has the A and the D antigen. Will they be A positive? If they have the B and the D. If you want to call that Rh factor, same thing, they'd be B positive. They have AB in this, they'd be AB positive. They got O in this, they'd be O positive. And you can look at it just opposite. If they have A blood, but they don't have the Rh factor, they're A negative. That'd be B negative, and so on down the line right there. So you're really just looking for the presence or absence of three things: the A, the B, and the D. But again, instead of using a letter for this one, you put a plus or a minus. Positive meaning it's there, negative meaning it's not. Now again, if you were to go to mixing the wrong types of blood together, these antibodies and antigens would go to binding together. That's what they mean by agglutination. A simple chemical reaction would bind them, and that would result in the destruction of those red blood cells. So again, you don't ever want to make an antibody that matches up with the proteins you have. You'd be destroying your own cells. And think about what would happen if you took some A blood and put it in somebody with B. Well, if you put these antibodies in this person, these antibodies would start to destroy the reds they had. And if you put this blood in this person, the antibodies they've already got would destroy the reds you put in them. That's why you don't want this. And if all those antibodies started to clump those red blood cells together, you'd have all these little clumps of cells. It looked like tiny little clots, not the same thing. It just looked similar. And all those clumped up cells would clog up capillaries all around the body. The person's liable to have a stroke, a heart attack, and many other problems all at the same time that could be deadly. Now, you sometimes hear about the universal donor being type O negative. Well, think about this. If somebody's O negative, that means they don't have the A, B, or Rh factor proteins on their reds. If they don't have any of those proteins on the red blood cells, there's nothing for an antibody to bind to. So you could put those red blood cells in any person that you wanted right there. Now, you would theoretically really have to remove the plasma because the plasma would have antibodies in it. But if you centrifuge the blood and remove the plasma, which would remove the antibodies, you could give the O negative reds to somebody all day long. So in one way, it's kind of a universal donor. If you look at it in another, it's not. And then AB here is also considered the universal recipient. Just some things you may have heard along with them. Looking back at that Rh factor right there, 85% of the U.S. population has it. So it's very, very common. O blood is actually the most common type, and since most everybody has the Rh factor, actually O positive is your most common blood type. And of course, if somebody has or doesn't have these right here, that's just another thing adds to their typing. But something else that goes with that Rh factor is sometimes there could be possible problems with different blood types during the time of pregnancy. If you've ever seen in the chapter in the lecture Hemolytic Disease of the Newborn, also called Erythroblastosis Fetalis, this is a time in which a mixing of blood types could occur before a baby is born. Let's say, just theoretically, that the baby has the Rh antigen and the mom doesn't. Well, usually it's not going to be a problem. Ordinarily, blood cells cannot cross the placental barrier. That means mother and baby can be of different blood type. Big misconception is that they have to be the same type. Absolutely not. If things go as they should, the blood types never mix. But let's say there were to be some kind of damage to that placental barrier, and some of the baby's blood cells that have the Rh factor get over to mom's blood, who doesn't have the Rh factor. If you ever get exposed to a foreign protein, I don't care where it came from, you're going to make an antibody to get rid of it. And if mom starts to make those antibodies against those Rh proteins, those antibodies could cross that placental barrier, destroy enough red blood cells of that unborn baby to kill them. So that could be deadly, but they have a handy little drug called Rogam that prevents the antibodies from being formed in the mother. So let's just say theoretically a mother, something like O negative, B negative, whatever. If she doesn't have that Rh factor, well, there's a very good chance that baby does. You can bet she's probably going to get that Rogam at that time. Here's some other terms. Go with this up here. Hematocrit. Now remember, hematocrit's never just a number. Always the percent that red blood cells make of your total blood volume. And again, that's ordinarily around 45%. Again, if you want to determine hematocrit on somebody, very easy. Just get you one of these little small, skinny hematocrit tubes. Might take about 5 or 6 drops of blood to fill one up. Put it in a centrifuge and spin it real fast. All the cells will go to the bottom of the tube, and all the plasma will be at the top. Then if you have a little measuring stick, say from 0 to 100, look at what percent the red blood cells make. ought to be around 45%. You can see there's a little bit of a difference between the two genders, right? Males tend to have a higher hematocrit and females a little bit lower. That's due for several reasons. Males tend to carry more skeletal muscle mass, and muscle requires a lot of blood, and they tend to have more reds. And females lose more reds due to menses and things like that. So there's usually a little bit of a difference. Polycythemia is where somebody's hematocrit is too high. In other words, they've got too many red blood cells in the blood volume. And that can get as high as something like 65% or higher. That means somebody's got a serious oxygen delivery problem if it gets that high right there in almost all cases. Anemia. Now, there are many different types of anemia, but there's two main ways to define it. Either somebody doesn't have enough red blood cells or not enough hemoglobin. So that's the two big ways you define anemia. You can make all the reds you want, but if you don't have enough hemoglobin in them, which is what carries the oxygen, they're not going to do you any good. So looking at counts right here, again, you can see the numbers per cubic millimeter a little bit higher with males and females, just like with the percent we mentioned above. And then with white blood cells, there's your normal range, about 7,000 per cubic millimeter is what you usually see. Now look at these other terms. You see leuko. Now remember that little prefix there means white blood cell. Cytosis will always mean too many, and pinia is going to be too little. So you could see something besides leukocytosis. You could see erythrocytosis. That'd be too many reds. Erythropenia be too few. So always remember, cytosis is too many, pinia is going to be too few right there. So there's just some basic information right there in our blood test and blood typing. We'll take a look at the Eldon cards and actually use some real blood to type here soon enough.